Kevin Kennard with Spiral X, here to show our Quad O compliant VTEX unit. Under the NESHAPS regulation subpart Quad O, our VTEX system is classified as a closed vent system. What that means is all of the vapors, as soon as it comes off of the still column from your reboiler, straight from our inlet all the way to the outlet to the method of destruction, there is no piping teeing off where venting could possibly happen. So we don't have upstream bypass where you could route it for routine procedures. There is a straight shot from the inlet all the way to the outlet of your emissions. And when you couple that with your electric pumps, zero venting is going to be on this unit. That's how we fall under the control aspect of the Quad O. And then with our updated electronics is how we conform to the monitoring and reporting aspects of Quad O and NESHAPS regulations. So real quick, Quad O, the NESHAPS regulation subpart Quad O highlights three major points. There's the control of emissions, the monitoring of emissions, and then the reporting of emissions. So on the control aspect, our VTEX unit can classify as a closed vent system under the Quad O regulations because it has no upstream manual bypass. And if you have something like that where you can manually throw it in a bypass and completely bypass these condensers, if it goes to atmosphere as a routine procedure, then you are then classified as an open vent system, which is not Quad O compliant. You fall under a lot more monitoring and reporting regulations with that bypass. If you do have that, you have to seal that closed so that you cannot bypass it under normal operating procedures. So a little bit about our tube bundles first. All of our tube bundles are manufactured with 304 stainless steel, headers, tubes, all that. You see we have an array of fin tubes for increased heat exchange. No pass plates on top or bottom, so all of the emissions coming in will have a straight shot to free flow down, and then all the collected condensate is a straight shot to our accumulator tank. No added pass plates, so you don't have to have any sections of drainage tubing, reducing your likelihood for freezing. All of our tube bundles are ASME coated. We do this for increased weld quality and documentation of all of our tube bundles. And you'll see up top, all of our tube bundles have concentric coupling ports for easy clean out. You can take off every one of those plugs and it's a straight shot down to clean out. And again, it'll rush out to the accumulator tank, or you can break the flange to have it drain out that way. Another thing I want to point out on the top of our accumulator tank is our safety divert valve. This is under the Quad O and NESHAPS regulations. This is classified as a safety device because it only opens up to the atmosphere under upset conditions to prevent hazardous occurrences from happening through your combustor or wherever you're routing these emissions. So if you get a high level in the tank or if something goes wrong with your combustor, this is set up to then vent to atmosphere, but it is not a routine venting or bypassing device. Therefore, it falls under the safety device of your Quad O and NESHAPS regulations. Now, moving on to the monitoring side of your Quad O regulation, we have a temperature transmitter. This is going to come standard on all of our Quad O compliant systems. This is going to monitor the temperature directly out of your condensers. This is something you need to monitor to make sure that your condensers are performing effectively to drop down the temperature underneath where your heavy condensate, C8s and things like that, roughly around 130 degrees. You want to keep it below that level to make sure that you are condensing properly. We're going to have that feed to our governance module on all of our Quad O feed plugs. So you see our 24-inch diameter accumulator tank. This is sized for all manner of upset conditions and startups. Sometimes you have a little bit of supersaturated glycol, so you get more liquid collection at startup. This is size for the maximum amount of all the largest size you can have of condensate production in our system. This is sized appropriately. This design is a dual electric pump and motor setup. This is a zero venting unit except for upset conditions, which is why we have the safety divert valve. The setup for our dual pump system, especially when you have electric controls, this will automatically switch between primary and backup pumps. If one pump or a level switch is malfunctioning and you're not getting condensate being released from the tank, once it reaches the high level switch for a certain amount of time, it will automatically switch over to the backup pump until it can go back down. If both pumps are running fine and it goes down to the low level, when it comes back up to the high level again, it will automatically switch roles from primary to backup. That way you're extending the life of your pumps and you have a more accurate picture of when a pump might be going out, because one is not sitting dormant for too long while the other one is doing its job as the primary pump. We are automatically switching primary and backup with every cycle. Go into our protective box to show our HMI. This is going to come standard on all of our control panels. We'll show briefly, real quick, how easy it is. So imagine you're on site and you're about to do startup. We have this laser etched QR code in here. This is really just a document database. Takes you to a web page where any drawings, GAs, P&IDs, wiring diagrams, things that we think would be helpful for everyone to be looking at and be on the same page with. We have this QR code here. Click that. So now it pulls up serial number. You can enter a location in there. We have helpful manuals. I can have the GA, so this unit that we've been looking over. You can see the dimensions and major equipment and connections. You go back, look at P&ID. And this is a web page URL that you can then copy and paste and send to others that might not be on site. And so now y'all are looking at the same documents, y'all can be on the same page. And that's where you can do a quick rundown of all the different level switches, your tanks, go from inlet to outlet, be able to quickly and conveniently look at any documentation through this. And this, it can be updatable for deleting and updating if you ever make adjustments or updates to the design. You see here we have our front overview screen. This is a P&ID depiction of the unit. So you have your accumulator tank, your dual pump system, and the safety divert. Safety divert and your dual pump system all come with an auto mode and a manual mode for startup if you want to manually run your pumps to check for rotation and manually enter into and out of bypass and normal function to test that out. And then if you're ever needing to send vapors to and away from your control device before it's actually hooked up with its status signal, you can do that here with the manual buttons and always switch it back into auto mode. See your level switches, and whenever they get activated with the rising liquid, you'll see them start to blink red, meaning they are currently activated. And then that will be able to show you whether a pump is running or not. This will show green and start to rotate those pumps. You also have an indication here at what status your safety divert system is, whether it's in the bypass or normal function mode. At a glance, this gives you all your inlets and outlets in one screen. As we go through the other screens, it'll break them out, but this is the all-in-one view. We have our quad OB monitoring and storing, so everything that gets triggered on here, bypass, a level switch, a pump goes on and off. Let's say you have the level switches are working correctly, but pumps are malfunctioning, so the 3 legs from the high voltages aren't working or hooked up. You get all of these timestamp, date stamp as to what was occurring. This can go back 5 years, which is the Quad-O requirement for data logging. This can go back further than that, but you can at any point in time go down here and convert this log into a CSV file for you to import into Excel and filter and look at it that way. Again, if you have, or if you desire to have the capability of monitoring your reboiler and your combustor, you do have that option here. Again, these are not hooked up currently with this system, but you do have that option. Another helpful tool is the first out screen. Let's say for whatever reason, you have either a high level in the tank or your combustor pilot goes out, reboiler shuts down. Any instance of that, if you had it connected, you would be able to see which one went out first. Of course, in an ESD, all of these systems are going to go down almost instantaneously, but this will be able to log which permissive was lost first. And so a person coming out trying to ascertain the situation, they will be able to come here on this screen and at least quickly rule out what was not wrong. If it's a high level, it'll show that the high level was the first one to go out. They'll know to target the VTEC system. If the flame goes out, the fire goes out, and the combustor, they'll know and see that here, and they'll be able to go and acknowledge that and move on to the next thing for a quicker troubleshooting process. So with our design updates and our electrical updates, we've been able to provide a Quad-O compliant system, both with control and your monitoring aspects of the NESHAP subpart Quad-O. This, as it pertains to Quad-O, listed as a closed vent system, is what routes the vapors from your dehy to your control device. This will be a combustor, or you have the option of routing it back into the reboiler with a fuel ring. Spiralerx offers both options, and there are much more monitoring and controlling requirements through Quad-O for control devices, which we will tackle in another video.